Good day. My name is Sarah Bouhazma. I'm a doctor from University Sidi Mohammed bin Abdullah, Faculty of Science. I will present my work titled Astrological Synthesis, Characterization and In Vitro Bioactivity of Binary, Ternary and Quaternary Bioglasses with High Mechanical Strength. This work realized in Engineering Laboratory of Organometallic and Molecular Materials supervised by Professor Mohammed Lashkar. Bioactive powders of the binary SeO2CaO, ternary SeO2CaO and P2O5 and quaternary systems with sodium and magnesium were synthesized by means of a solder route. The gels were converted into bioglasses powders by heat treatments and at the temperature 700 degrees Celsius. The resulting materials were characterized by X-ray diffraction, Fourier transform infrared spectroscopy, environmental scanning, electron microscopy, and in vitro bioactivity in a cellular simulated body fluid. In the present work, we will focus on comparison the bioglasses magnesium-containing SeO2CeO P2O5 Mg with binary with two elements, silicium and calcium 17,7B, ternary with phosphate and quaternary with sodium 25In8. Bioglasses 77B and ternary and quaternary with magnesium and sodium were synthesized by a solder technique characterized for their physico-chemical properties. The compositions of the system were listed in table 1. We have 5 glasses with different composition and different elements. Binary composite with two elements, silicium and calcium, ternary with other elements, phosphate, quaternary with sodium and magnesium. For in vitro study, to evaluate the bioactivity of the synthesized materials, in vitro tests were performed according to the method described by Kokibo and al. It is important to mention that this solution is often used in the in vitro evaluation of the formation of a hydroxycarbonated apatite HEC layer on the surface of materials designed for implants. We must mention the SBF is elaborated in our laboratory with the Kokibo process. For mechanical strength of synthesized bioglasses, we use the compressive strength measurements carried out on universal testing machine model Enstron 3369 equipped with a 2.5 load cell cylindrical sample, and the specific attention was paid to the good parallelism between the flat surfaces under compression. The testing speed was set at 0.1 millimeter for minutes. Study of porosity for these glasses to try to quantify the total porosity of the bioglass. A measurement of the relative density in an aqueous medium is made. The porosity is very important. This glass must be plus 50% for porosity. The essential condition for a biomaterial to bond with living bond in the formation of a surface apatite layer in the body environment. To determine the bioactivity of these materials, the bioactive glasses samples were immersed in SBF at approximately 1 milligram per milliliter and maintained at 37 degrees Celsius for 6 to 214 hours. X-ray diffraction and FTR evidenced the formation of an apatite-like layer on the glass's surface after soaking in SBF. Figure 1 shows the X-ray diffraction analysis of the four glasses, binary, ternary, and quaternary bioglass with the sodium and magnesium. All glasses are bioactive by different times. The patterns obtained for the glasses after soaking don't exhibit peaks characteristic of hydroxyapatite. Compared with the amorphous structure before immersion after 2 days of soaking, the day pattern of simple centroid at 700 degrees Celsius showed one wide diffraction peak corresponding to the peak 211 reflections of an apatite phase. Bioglass 1570 is more bioactive than the bioglass 177B. Figure 2B shows diffraction peaks corresponding to the 002 and 211 reflections of calcium phosphate carbonated hydroxide after 1 day of immersion in SBF. The quaternary systems with the Na and the Mg are bioactive, but both elements behave differently. For FTR analysis, this figure shows the FTR spectra of samples before soaking in SBF. Before soaking, the spectra of the sample exhibited SEOSE stretching and bending bands. The band at around 1018 corresponds to the vibrational mode of this asymmetric stretch of SEOSE. The band at 800 corresponds to the symmetric strength of SEO, and the strong band at 475 corresponds to the vibrational mode of the bending of SEOSE. After soaking at various times, additional peaks appeared around 515 and 600 to twin bands at 517 and 600, which correspond to antisymmetric vibration mode of PO in amorphous calcium phosphate. The bands at 1413 corresponds to carbonate and 3415 corresponds to water. All bands indicate apatite formation in SBF. This data confirm the XR day findings. For results of mechanical strength and porosity, we can say, despite the vast literature describing the mechanical properties of different types of glass ceramics, there are only few studies concerned with bioactive glass ceramics, and particularly for this family of highly bioactive glass ceramics. Several studies have compared the mechanical behavior of the parent glasses with fully crystallized glass ceramics. We present the result in this table. In the present work, we independently studied one microstructural factor that affects the mechanical behavior of the material, the porosity of each glass. For glass with the sodium, we can observe it. It is very comprehensive, and with the 16.6% of porosity. The ternary glass present modest compression strength with highly porosity, 19.1% of porosity. We can say all glasses are a good percent of porosity, and in compressive strength is modest. Finally, I want to say thank you for your attention, and especially thanks for organization committee.